Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about auto power density spectrum concept and its properties, and also discussed about relationship between autocorrelation function and auto power density spectrum. Now here in this video, I am going to discuss about cross power density spectrum or cross spectral density concept. The power spectral density of a random process x of t provides a measure of the frequency distribution of a single random process. So similarly, the cross power density spectrum provides a measure of the frequency interrelationship between two random processes. So two random processes mean x of t and y of t. Consider two random processes x of t and y of t, and one of their sample functions are small x of t and small y of t respectively. So capital X of t and capital Y of t are the two random processes, and with their sample functions are small x of t and small y of t respectively. Let xt of t and yt of t be defined as the portion of the signals x of t and y of t between the limits minus capital T and plus capital T, that is xt of t is equal to x of t over minus capital T to plus capital T, and yt of t is equal to y of t minus capital T to plus capital T. So we know that using definition of the Fourier transform, x t of omega and y t of t of omega are Fourier transforms of x of t and y of t. So that are Fourier transform of x t of t is x t of omega, which is equal integral minus capital T to plus capital T x t of t into e power minus j omega t dt. Now here the signal x t of t is equal to x of t over the interval minus capital T to plus capital T. In this interval, x t of t is equal to x of t, which is equal integral minus capital T to plus capital T x of t into e power minus j omega t. So this is the Fourier transform of the signal x t of t. Similarly, the Fourier transform of the yt of t is equal yt of omega, which is equal integral minus capital T 2 plus capital T yt of t into e power minus j omega t dt. In this interval, yt of t is equal to y of t. Therefore, yt of omega is equal integral minus t to t y of t e power minus j omega t dt. Now we define the cross power Pxy of t. So Pxy of t is the cross power. So we can define the cross power in the two random process within the interval minus capital T2 plus capital T. So within the interval minus capital T2 plus capital T is defined as, so that is Pxy of t is equal 1 by 2t integral minus t to t x t of t y t of t dt is equal. So but x t of t is equal to x of t and y t of t is equal to y of t over the interval minus capital T to plus capital T. So therefore the cross power Pxy of t is equal 1 by 2t integral minus t to t x of t y of t dt. So by using Parseval's theorem, Pxy of t is equal, this finite value is equal, using Parseval's theorem, 1 divided by 2 pi integral minus infinity to infinity xt conjugate of omega into yt of omega divided by 2t into d omega. So using Parseval's theorem, the power signal is equal to 1 by 1 by 2 pi into cross power signal, 1 by 2 pi into cross power signal. That is, this is the equation using Parseval's theorem. So by taking expected value into the above equation, in the above expression, taking expected value into the above equation, we obtain the average cross power is P suffix xy bar of t is equal and also taking the limit t tends to infinity on RHS side, we have limit t tends to infinity expected value of the RHS term of the previous equation. So that is 1 by 2 pi integral minus infinity to infinity expectation of xt conjugate of omega yt of omega divided by 2t into d omega. So interchanging order of limit and integration, we have the RHS term is 1 by 2 pi integral minus infinity to infinity limit capital T tends to infinity expectation of xt conjugate of omega yt of omega divided by 2t into d omega. So which is equal to this value is equal which is equal to pxy bar of t is equal 1 by 2 pi integral minus infinity to infinity xy of omega into dy, where sxy of omega is the cross power spectral density of the random process x of t and y of t, where sxy of omega is equal limit t tends to infinity expectation of xt conjugate of omega yt of omega divided by 2t. So by using the same procedure as above, we can also arrive at the average cross power process s yx of s yx of omega is equal limit t tends to infinity expectation of yt conjugate of omega xt of omega by 2t, and the average cross power is p yx bar of t is equal 1 by 2 pi integral minus infinity to infinity s yx of omega d omega. So this equation is called as cross power density spectrum or cross density spectrum of the two random process x of t and y of t. So this is the concept of cross power density spectrum.